everyone, this is KP the Math G here. We're going to work on a little bit of calculus today. It's going to be my 144th video, and this comes from the 2029 free response question number 3. This is a graph of F. As you can see, these are the areas underneath each one of these triangular curves, and then this is the area underneath this curve. And if you would look at the last 2 videos ago, I showed how to get each one of these, and we did problem or question A with that. And we're going to attempt to do for this time question C. Let me give the question C problem out here. Let's put it out there. Alright, so we're given that g at x is equal to, from, let's see, -2 to x, f at, let me see here, f at t dt. Alright, that's what we're given, and what we want to find, let's see, the absolute maximum. Alright, and it's going to be on this interval from -2 to 5, so let's go ahead and say that on the closed interval from -2 to 5. I believe it is the closed interval. Well, one thing about this, we're probably going to have to work on the other side. I may try to put everything over here. There are certain things that I can get away with without having now. So let me see if I can erase some of this. Okay, let's see here. I don't think I'm going to need any of this really. So I may have a little room to work with. We might even erase this now. Alright. And let me check where I'm at. This thing moved over a little bit. Let me check where I'm at. Excuse me just for a little bit. I'm so sorry. There we go. Alright. Now, I think we can get started now. I do apologize for this. I usually am a little more prepared than this. Okay. It's Sunday, it's a lazy day, and, well, still no excuse for me being a little bit lazy, but anyway. This is C part. We're going to go ahead and do that. Let's look at what this thing is saying here. We want to find the absolute maximum. Now, to do that, we got to remember a couple things. One thing, this phrase, absolute max. If we're given G, we want to remember then that we want to take the derivative of this side, which is just G prime. Let's put it up here. So G prime at x, we've got to have that. I'm not sure that that's a full point, but I think you do get a point for that. And the derivative of this side, what is that? Yeah, that's right, it is f at x. Well, keep in mind that this is a graph of f right here. So what we're looking at is this f at x. So that's what we've got to remember. The second thing we've got to remember is that when we're talking about the absolute max, and I've got lighting issues, and this bulb is brand new and it still blinks. I don't know what the deal is, ghostly or whatever, I don't know. Hopefully we can still do the lesson, and if not, we'll do it some other time, but stay on, boo-boo, stay on. Okay. Alright, absolute max means we have to look at the extreme value theorem, so we have to look at the endpoints. Alright, so if we're looking at, in this case, x, now remember we're not looking at f at x, we're looking at g at x. So whatever we find here, we need to plug the answer into this x right here. So in other words, we're definitely looking at -2 and 5. And we got to find some other places. Now if this is f prime at x, which it's not, it's f, sometimes it's f prime, then we would have to be looking at other things too. For this to be a max, you would say, well, increase, decrease, there's your max right there. That would be at -1 for sure. Some people would go ahead and look where f at x equals 0. F at x equals 0 at, well, actually also 5, but 5's already an endpoint. But at -1, x equals -1, and x equals 1/2. I'm not sure we're going to really need the 1/2, but if you want all the points, you might better go ahead and throw that in there. So -1 and 1/2 right here. Okay, so we're going to look at these answers here and see what we get. Alright, now get a different color. I'll have to use different colors from time to time. Let's see what g at x is. If we plug in the -2 right, well, let's see, hold on, let me erase this. Again, I apologize for any inconveniences here. I'm a little slow today. Alright, so what we're looking at is g at -2 is equal to -2 to -2 f at t dt, which, by the way, what happens if you go from -2 to -2? Yeah, that one is 0. No problem there, huh? If we plug in 5, alright, we are plugging in 5, the other endpoint, and we have to really just look at all of these areas from 5 to -2. These really cancel each other out, don't they? So that's really 0. So what we really have is equal to -1/4. Remember, if it's below the x-axis, it's going to be a negative area. And then this one's going to be 9/4, so plus 9/4. And then plus, this is 9 minus 9 pi over 4. So what this turns out to be right here, -1 plus 9 is 8/4. 8/4 plus 9 minus 9 pi over 4. Now, if you look at this real carefully, 8 over 4 is 2. 2 plus 9 minus 9 pi over 4, which is 11. Oh, 2 plus 9 is 11 minus 9 pi over 4. Cool. Alright, we got that one. Alright, now that is positive. I can't remember the answer to this, but it is a positive answer. We do want that. We want the greatest one. We know that this is greater than this. Alright, so far we're checking off that one. -1. We're going to keep going in spite of the light. We're just going to keep going. I think we've got enough light to do this. Alright, -1. What do we get? So if we go from -1 negative 2 to negative 1, that is only 1/2. Okay, so 1/2 here. Alright, 1/2 right up here from, well, actually, positive 1/2 here. So negative 2 to 1/2. Remember, these two cancel each other out. We're left with negative 1/4. And so far, this is, we'd have to look. We can't do this one. We know this one's greater than 0, so this one's out. Is this greater than that? So you'd have to look at that and see if that is. And we can test that just right now. Alright. I need to get out my calculator here. And let's see what we got here. I do have it already. 11 minus pi over 4. I don't have a value for that. Let's see. Yes, 3.931. So this is about 3.931. That's what I thought it was. So this is about 3.931, which is greater than 1/2. So we would say then, therefore, the absolute max occurs when x equals 5. Alright, if you want to, if you have this out here, that is fine, and I do believe we may have enough to say that. Okay. Say what we need to say. Yeah, that's it right there. And I guess maybe it is on the interval. Okay. I think we already have that, but we can say it right here on the interval. Okay, negative 2, 5. If you were looking for your absolute min, this would be it right here. Okay, this would be your absolute max. This is your absolute min. There is a difference between absolute max and absolute min, and just your max and your min. If you're only looking at endpoints, you would look for your absolute, just your relative max and relative min. But we're looking at the absolute. That's usually what they're going to ask for, is the absolute, which means, do you understand the extreme value theorem? Okay, which means that you must include the endpoints as well. If you're looking at a graph of f or g or whatever, usually it's going to be f. If this is a graph of f, you must consider where the points intersect. Okay, and then that's actually where the zeros are. Alright, so there it is. Alright, so that's it right there. I am going to go ahead and do part D, so let's look at that. It has to do with limit. So again, if you're a teacher, or if you're a student, or someone's getting ready for the next, for the BC class, this will be good review for you. And if you're getting ready to teach this for the first or second year, this will be good review for you as well. And believe me, I'm no guru at it. I just practice and practice with it, and that's what you're going to have to do. You're just going to have to practice and practice with it. And if you're a new teacher, you really need to look into what the syllabus, the AP syllabus, is all about. If you can get that, then that would help you quite a bit right there. And you can work on that and work on any kind of AB material that you can get. I got to 2019. I've started all the way back to 1997 or 1998, and you can get all kinds of problems from this. This is really good exercise here on this one. Okay, so let's look at this last one here. This is D part. This is the last one. So we want the limit as x approaches 1, and boy do they have a nice limit here. I'll say nice, boy, it looks intimidating at first, and that's what they I don't know if they really and truly want to intimidate anybody, but this can be intimidating, but it's not as bad really as it looks. Boy, look at that. My goodness. Then they put over here arctangent. Okay, of x. Okay. Oh, alright, put that down there. Alright, I don't even think they use a parentheses around this. Alright, and so the limit is 1. And what we have to do with this is make sure that our denominator is not 0. And let's just look at this. This is the graph of f. I'd like to try to just see if I could plug the 1 in right off the bat and just go with that. You know what? Just to give you a little hint, it does work. I like that. Alright, so 10 to the 1. That's not so bad. That's just 10. 3 F prime at 1. Now I got to find what that slope is at 1. Okay. F at 1. That's easy to do. Just look at 1 and find out what that is. And then minus arc. Oh boy, arctan. Boy, they really want to make this look really hard. I do want to look at, we know this is 10. F prime at 1. That's the slope right here. We want to look at that slope right there. Well, let's see, rise over run. So 1, 2, 3, 4. This is M is 1 over, okay, and then 1, 2. Alright, so 1 over 2, that slope is 1/2. So that is F prime at 1 is, I want to say, that is 1/2. F prime at 1. Yeah, I think so. So 1, 2, 3, 4, and then 1, 2. Oh, it's 4 over 2. My bad. It's not 1/2. It's 4 over 2. What did I do? KP 4 over 2, which is 2. I knew something didn't look right. So the limit at the top is going to be really easy, isn't it? 10 minus 3 times, well, we know that slope is 2. That's not so bad. F at 1. Now, I got to figure out what this is. F at 1. I'm just having to think just a little bit about how I can find out what F at 1 is. Let me see. I want to say that F at 1 is 1. Okay. Now how I figured that out, let's see if we can. I do know that there is an equation, y minus y1 is equal to m times x minus x1. Okay, so I know that this slope is 2. Alright, right there. And if I want to put in, let's see, maybe I can put a point right here. It doesn't matter which 2 points I pick. Let's pick this point right here. So we got y minus -1 is equal to 2 times x minus 0. Okay, now actually what I want to find out is what it is when x is 1. So I can actually put a 1 right here. Okay, x is 1. Alright, so 2 times this is just 2. Alright, y plus 1 equals 2. When I subtract 1 on both sides, yeah, y is equal to 1. So yeah, y is 1. LFIT 1 is 1. Okay, that's good enough. Now, let's look at arctangent. Boy, isn't that fun to do that, is look at arctangent. Think about this, teachers, guys and girls, men and women. Alright, so let's see. Usually we write, if we say arctangent of 1, well, okay, let's make it equal to some x or y or whatever, is equal to x. We'll just do that. And that just simply means that 1 is equal to tangent of x. So tangent of something is equal to 1. If I were to multiply both sides by tangent, I would get this here. Okay, so 1, and then what we'd have to do is we would have to figure out what value of x is tangent of that equal to 1. I remember that we had a table a while back that I know that tangent of 45 degrees, if you have it in degrees, that's equal to 1. So what we want it is in radian measure, okay? So tangent of pi over 4 is equal to 1. So 1 minus pi over 4. And one thing about it, this is not going to be 0. So all we really have to do is figure this out right here. The numerator is all we need to do. Alright, so this is equal to 10 minus 6. If we do the limit, x approaches 1. 10 minus 6. Yep. Over 1 minus pi over 4. Don't get careless here. 10 minus 3 is 7. 7 times 2 is 14. Don't do that. Alright, we know not to do that at this level. 10 minus 6 is 4. Now we don't need to have the limit sign at this point. So 1 minus pi over 4. Okay. One thing that I have found here is that remember we had this table. I think I'm gonna have enough time. My thing here, my camcorder here, it just seems to go out after 30 minutes. So I hope I'm not going to go over. If I do, we're done here with this and the other problem. Okay. Remember we had, we had sine, cosine, and tangent of 0 of, I want to say 30, which is pi over 6, pi over 4, of pi over 3, and then we had pi over 2, didn't we? And that's all in quadrant 1. And of course, remember this one here, sine of 0, 0, 1, 0, so 1, 0. Remember 1 over 0 can't work. This one would be 1, let's see, pi over 6, a half rather. Okay, a half would be down here. Square root of 3 over 2, square root of 3 over 2 over here. Alright, and then this would be 1 over the square root of 3, numerator over numerator. This would be square root of 3 over 1, and then this would be the square root of 2 over 2, or 1 over the square root of 2. And then of course this over itself is 1. Okay, sine over cosine. Okay, this is 1 right here, so that is pi over 4. Okay, and that's where I get that. I just remember that table like that. That's what I do when I'm doing this. Let's just go back over that table. Alright, there it is. So that's part D right there. There's your limit there of this. Good thing this doesn't turn out to be 0. If this was 0 and this is 0, we could do L'Hopital's rule, and we don't even have to worry about that. So, anyway, that's C and D. And remember, when you have absolute maximums, you have to take the derivative of both sides, but you got to plug back into the original. Okay, always remember to do that. And also remember that you have to test those endpoints and where the graph crosses the x-axis. Okay, that's especially if you just have F. Okay. All right. Well, anyway, this is KP the Math G, getting ready to sign off. Ladies and gentlemen, I appreciate you very much. If you want to hit that subscribe button, please do so. If you want to make a comment, please do so. If you want to make a like, you see I already smile when I say that. Hit that like button if you'd like to. And anyway, I appreciate you guys, ladies and gentlemen, very much. If you don't do any of this subscribing or whatever, it's not for my glory, but it's for your benefit. Alright, well, that's KP the Math G signing off. Ladies and gentlemen, have a great, great day.